I would, if I were you, practice it a couple of times on my own just to make sure that I knew how to do it. Not that I'm hinting at all about what specific problems will be on the exam, but that may be something that a good student would like to practice. So, let's talk about Hess's law. Hess's law is kind of a, I think of it as sort of a fun little mathematical puzzle. That's how I think of it, anyway. And I don't think you'll find it's that bad. It's whether it's fun or not, I'll leave that up to you, but it is a mathematical puzzle. What we do in Hess's law is use given equations in order to figure out the delta H of unknown equations. Okay? So, thermochemical state functions can be given for certain chemical equations. There are a lot of very simple reactions that have given chemical equations. In lab, you figured out delta H for that reaction A and reaction B. Okay? What we can do then is manipulate the chemical equations and look at how delta H gets manipulated right along with it. Okay? Doubling the coefficients will double delta H, and so on. So if this is our given one right here, look at those coefficients. Okay? Now compare it to this one. What should I do with this value to figure out delta H of this equation? Yeah, 2 times negative 483.6. Okay, that's not so bad. What about for this one right here? Yeah, we can do 1/2 times. In thermochemical equations, because those coefficients just mean moles, we can have fractions now for coefficients. Okay? Those can be whatever we want. It's just if we have a certain starting point, whatever we do to the coefficients, we do the same thing to delta H values. Okay? That's not so bad. Reversing an equation will change the sign of delta H. Because now, instead of going reactants to products, if we're going the other way, the heat has to be transferring in the opposite direction. So look at this one. This is going to actually take 2 operations to get from our original known one. Okay? What will we have to do to that negative 483.6 in order to get this one? Yep. So what's the single mathematical thing that would do that? We would multiply it by, yeah. So if we do negative 3 times negative 483.6, we get that. Okay. And I'm not writing answers here because that's all arithmetic that you guys know how to do. Okay. So when we add equations, we will add their delta H values. Now you're thinking, what does that mean to add a chemical equation? Well, it's a lot like what you would think. If we have, on the reactant side, if we have 2 of the same thing in equations we're adding, if we've got 1 water and 1 water, we add them together, we get 2 waters. Okay? So you add coefficients that are on the same side. Okay? Substances that are on opposite sides, their coefficients can cancel. Okay? It turns out. So let's take a look at what has to happen here. Here is our unknown equation. This is the one we want to figure out delta H for. Okay? That's just some reaction, whatever. But we've got these known values here. Our job is to take these known equations, identify portions of them that show up in the unknown equation, but then also figure out if we have to flip it around or if we have to multiply or divide it, okay, in order for these to add together to make that one. Okay? So I think the first thing that I would see is that I got 1 CO here in my unknown, but I've also got 1 CO right there. Okay? Which tells me that this equation, same thing with CO2, tells me that this equation is probably correct as it is. Okay? But then look at this other one. We need to get this NO over here on the left side of the equation. What are the things that I'm going to have to do to arrange this equation so that NO shows up there? What do you think? You have to divide it. Okay? So essentially you have to do times 1/2 or divide by 2. Anything else? Yeah. Because, so look, we've got 2 NOs over in the product. What I want is 1 NO over in the reactant. So that 2 needs to become 1. Coefficients we can manipulate by multiplying or dividing, right? So what we're going to write here, we're going to say times negative 1/2. Okay? And I'm going to rewrite this equation essentially times negative 1/2. The negative does what? Flips it around. And the times 1/2 does what? The 1/2. What does the 1/2 do to the coefficients? Yeah, it divides them by 2. It essentially multiplies 1/2. So if I do times 1/2 by this equation, what am I going to have over on the left then? I'm going to have 1NO. And then over on the right, what am I going to have? But what about their coefficients? This is 1. That's 1. We're going to have half N2 and half O2. Okay? Coefficients can be fractions. Okay? You have to take these 1s, multiply them by 1/2. Okay? So delta H for this would be negative 1/2 times 180.6. Right? And then what we can do, because we changed this one, what I sort of like to do is just draw a single line through it just to know that we're kind of done with that. But then, look what happens. Just by sort of identifying the unique parts, right? Here's an NO on the left, here's an NO on the left. Okay? So let's add these two together. We've got CO plus 1/2 O2 plus NO, right? These are all the reactants over here. CO, 1/2 O2, NO. Okay. CO2. One half N2. Oops, let's do blue. One half O2. Okay. Right? Because I took CO2 and I had these all in the products. I'm just combining, right? No? CO2 from this one. 1/2 N2 on this one. 1/2 O2 on that one. I'm just taking all the reactant. Yep. Reaction A with reaction modified B here. Okay? Your ultimate goal is to sum these together, but this can be simplified, right? What simplifies in this equation? The O2 simplifies because I've got 1/2 O2 on the left and 1/2 O2 on the right, and those go away. See how that works? So we did it, right? CO plus NO makes CO2 plus 1/2 N2. And to get the delta H of this unknown equation, we have to do negative 283.0 plus negative 1/2 times 180.6. If you want, you could just get a value for this one, or you could enter them in all at once with parentheses and proper order of observations, like that. But our ultimate goal was taking our given equations, okay, rearranging them so that they would be able to be combined into the unknown equation, okay, using the delta H values sort of like we talked about. Okay, so anybody get an answer for this? That is not quite what I got. That is also not quite what I got. That's what I got. I wonder if there are order of operations issues here. If that didn't come out right, be very careful with how many things you're entering all at once. If that didn't come out right, if I were you, I would do negative 1/2 times 180.6, or 180.6 divided by 2 with the sign changed, or something like that. And then make sure it's negative 283. So it's going to be a number that's more negative than 283. So yeah, I get negative 373.3. Okay. So make sure that you can do your order of operations right. It would be crummy to do all the Hess's law stuff correct and get everything right, and then do the arithmetic wrong at the end and get the wrong answer. Okay? All right. Let's give it a try. Here is our unknown reaction. The first thing that I would do would be find unique and familiar things in our known reactions and figure out where they need to go to have them be in the same place and the same coefficient. Okay? So, for instance, I would start with the NH3. Okay? Don't try to arrange N2s because there's lots of things with N2s. Okay? Those are going to have to cancel at the end, and if you get the rest of the stuff figured out, they'll work. So I would, like I said, start with NH3. Maybe rewrite an equation, okay, that shows what you had to do to it to get it in the right place, and then after you rewrite it, maybe cross out the original one. Also focus on unique things. Okay? I would not try to deal with O2 because you got O2 in both of those. Okay? That's going to be tough. But I would try to deal with NO. Okay? So you can get yourself into trouble trying to get all these things to match up. Start with just the unique things. Okay? So try to get NH3 in the right place over on the left. Right? Try to make it 4 NH3 over on the left. Okay? Try to make it 4 NO over on the right. So start by maybe rewriting number 2 down here in a modified way so that NH3 is in the right place. And think about specifically how you modify it. We can reverse reactions. We can multiply the coefficients by something. And then I would even, let's keep this simple. I would update the delta H values as you go, right? I think that'll keep you a little more organized. So if you're doing times 4 or whatever times a reaction, do the delta H times 4 and write down that actual updated delta H. That'll keep things a lot better organized for you. And a lot of times the reactions will be numbered or lettered. You can sort of use that to keep track of what you're doing too. So when I say -2 times reaction 2, that would look like this. So yeah, let's just update our delta H values as we go. As long as you don't round anything, then so for instance, I have 183.6 for my modified number 2 reaction, because I needed to reverse it, okay? And I needed to make 2 into 4, essentially. So that becomes 4 NH3 over here on the left. That's what I missed. Yep. If you've kept them updated, then you just add them all up. What was the next reaction somebody did something with? The oxygen to 5. that's going to be a little problematic because we have oxygen in reaction 1 and in reaction 3. So let's not deal with oxygen just yet. Let's stick with the unique things. And then what happens if you stick with the unique things, then all the other things will sort of cancel out and combine the way they need to. It's kind of like magic. Once you've figured out what to do with each of the 3 reactions, okay, if you've done it right, everything else will fall into place. So, yes, because H2O is unique on here, right? And we need to get 6 H2Os, and we only have 2 H2Os. So let's do 3 times reaction 3, but not change the sign. So 2 times 3, 6 H2, 3 O2. Yep, you multiply the whole thing, every coefficient.
So do you have to multiply the second one, like the whole thing by 2?
Yep. Whenever you multiply a reaction, all of the coefficients get multiplied. Okay? So I did -2 times the reaction 2. So that's why that 2 became, the negative just switches it. Okay? 2 became a 4. 1 became a 2. 3 became a 6. We said 3 times reaction 3. 3. Yep. 3 times -483 point. Okay. Negative. Okay. So we figured out what to do with equation 2, equation 3. What about equation 1? Yep. Let's double equation 1 because of the NO. So, see how that works? So, 2, 2, 4, so 2 times 180, 361. Okay. So then, to check your work, we should be able to add all of this up, and it should equal our unknown equation. Okay. What you can do in the meantime, though, to actually save some space, if you got something on the left and the right, you can just cancel it. Right? So what's something that just totally cancels here? The N2s, 2N2, 2N2. 6H2, 6H2. Right? Because then what happens to the O2s? They add up. See that? So what you'll pretty much always be able to do is find unique things from the reactions and figure out where they go. And I say unique things because if something shows up in multiple reactions, look instead at something unique, and those multiple things will either cancel out or add together like these O2s did. See that? I did times 2 because we had 2 NO here and we needed 4 NO up there. So I doubled it. So I found the unique part of that one that matched what was up above. Okay? So who got an answer? We need an answer before we go. Yep. Okay. So some of you will really, really have to practice this to get good at it. Some of you, this is just a little math problem, little math puzzle, not a big deal, but definitely practice up on this. Okay? We're done. See you next time for the exam.